All right.
So yeah, I'm David Corrado. I'm gonna last time I went over a few Swift design patterns in general. And today I'm just gonna go through the last three creational design patterns. So last time we talked about um the with the creational ones, we did the singleton pattern and the builder pattern. I think most apps you've seen those, but the last three these creational patterns that I'm going to walk you through with the creational ones are a little bit more difficult to wrap your head around. So I'm just going to quickly kind of go through it and chat about them. Let's see here. Okay. So the first one I want to talk about is abstract factory. So abstract factory is a creational design pattern that allows you to produce families of related objects without specifying their concrete classes. So I stole this basically from a website that I'll reference at the end. But essentially, it's like a class that can create multiple related things. So, for example, you can like maybe have an example I saw on the website was a factory that generates furniture, and you can have a modern furniture factory that you create off of that, and maybe a classical furniture factory that you create off of that. So it'll make more sense when I this is another great example is you're creating a UI in an app, and you almost kind of abstract out exactly how you're building stuff. You have a button and a checkbox, but if you're on a Mac, it's going to be a Mac button and a Mac checkbox. And on Windows, it's going to be a Windows button and a Windows checkbox. So you basically have a factory that has functions for creating buttons and creating checkboxes. And then in your application layer, you can choose, hey, I'm loading on Windows, so I'm going to load the window factory. On Mac, I'm going to run the Mac factory. So this is quickly a Swift implementation of that. I wouldn't worry. I'm gonna. There's another pattern I'm going to show you immediately after this that is gonna like kind of maybe confuse you. But the main thing that we're doing here is we're creating a factory. Like this is a shape factory that creates multiple different kinds of objects. So it's going to create a circle and a square, and then you implement it over here. This is a concrete implementation of the shape factory, and it creates the circle and the shape here. So then essentially you just create the usage of this is where it starts to make sense. So you're actually just creating a concrete shape factory, creating a circle and creating a square. But you don't really necessarily need to know what circle or square you're actually implementing. So the factory method and the abstract factory like kind of sound the same to you at some point in time. So I'm going to show you the differences between them. But a factory method is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. So essentially, it's just an interface that says, like, for example, a logistics interface. And let's say you want to drive on the road, you would create a road version of that allows you to drive on the road, and then a C version that allows you to drive on it. And I'll have a better example of like comparing these two. But essentially what this is it's almost exactly the same as the other implementation, but you define a protocol, which is like an interface that defines that you're drawing, and then you have the circle and the square implemented. And then essentially what this makes this different is that each basically you have a shape creator and a circle creator, and you can actually just create a then you also have a square creator. So you just use this creator to actually create the two different objects. So rather than having one factory that actually has a circle and a square inside of it, you just have two different creators, one for and the output of it is a shape. So you don't really care about the output here, but essentially you're creating a circle here, and then you're creating a square. Like with the actual use cases of this would might be a little bit like abstract, but my main point of this is to understand like the difference between the two, and you'd have to figure out the use case of this. I've actually never used this pattern before, but this actually shows you the difference between the abstract factory and the factory method. Essentially, the difference in the isn't like focus on the usage is here you're actually create this is the actual abstract factory. So you're creating the factory, and off of that one factory, you can create a circle and a square. So then with my example, you can have a modern furniture factory that you actually implement, and then you create a chair, and then you create a sofa, for example, here. But in this example, you would basically just create like a modern uh, circle fact creator, and then you would create the circle, and then you would do a modern square creator, and then you create the square. So essentially, it's like just different ways to implement this. And these are two of the other creational factors. There's one more that I'm going to walk you through real quick, and feel free to interrupt me. The last one, is the prototype creational design pattern, and you probably have thought about it. And this essentially it allows you to copy an object, but the important thing about this is it kind of allows you to define an interface for copying an existing object without. So the point of this is if you think of like a multi-module app, you can kind of pass the interface to another module, and then that you don't care about the implementation details. You don't pass the actual struct or whatever class to the other module. So you kind of decouple the two things. But this is a relatively complicated example, but essentially you have a shape here that generically can copy the object. This would be the base class that you extend, and it basically grabs the ID, and then this circle actually would the circle implementation of it would copy it with the radius and the can't read the top of this. This is a square. This would essentially do the same thing, but with the square parameters. So then you can just kind of generically copy these things and not actually pass the circle or square directly to anything. You kind of just use the interface, hypothetically, you could pass the interface between classes. But that is essentially what I had. The three additional design patterns that I thought were useful. There's a ton more of the other types, which are behavioral and structural, that I think are interesting to explore. So I'm gonna keep exploring those. But does anybody have any questions of those? I feel like those patterns are probably not ones you're gonna use a whole lot. But I just wanted to slam through a few more design patterns to kind of get familiar with them and what they mean. And then also you keep them in the back of your mind for, do I have a use case for actually using this? And like I gave in my original presentation, which is a little bit more detailed, you shouldn't cram these in for solutions of problems. If you have a use case that fits for it, use it, but proceed with caution, because you could be making your code more complicated unnecessarily.
They're like templates that you can adjust for your use case.
The design patterns? Yeah. So the backstory is a long time ago, there's these guys named the Gang 4, and they basically created patterns. And for the most part, they're like relatively static. If you look them up, they're all the same, and the implementation of them is mostly the same cross-platform. So I just did this in Swift, but the premise is some of these design patterns are actually like going away because languages are natively making it super easy for you. So some of these things like you don't really find used very often. But yeah, essentially, yeah, they're tools to consider using and to architect to solve problems. So for example, if you have a 15 different furniture factories, you can kind of use that interface pattern. And you probably indirectly use these patterns without even knowing them as well. So, but yeah. Anybody have anything else they want to talk about with this?
I think that's recorded.
Yeah, I've never really like leaned into abstraction as further than just like for the use case of like testability, right? Like everyone knows how to wrap your concrete implementations with an interface so that you can make it easier to test, blah blah blah, and like you can have some level of modularity, which you can leverage, facades in the same fashion as prototyping. But like in my day to day, it really comes into play because when you work on an SDK, you have to be very conscious about size, right? So like you can think about a library that knows how to do a specific amount of things, but you can, abstract out specific large modules that contain a large amount of files to do a specific feature. But if a partner doesn't want to use that feature, they don't want to pay the cost to have that code inside their SDK. So like you think about like Microsoft Teams is massive. So like we can't add features larger than 2 kilobytes without reason. So what you have to do is I say fancy, but like you have to get very, very intricate with how you build your features, so such that they're behind a prototype or prototype in your sense, but we call them like facades in house, where the core knows about what the facade does, and it knows like there's a facade that exists, and it would know what to do with it. But a concrete implementation lives in a module that if the partner wants to use that feature, they just have to reference that dependency, bring in the instance of the interface, and throw that into the library. And that way we can subset a lot of the size to a different module that you don't have to pay for unless you want to use that feature. So it gets really interesting. But at the end of the day, it's just an interface that the core knows about the interface, but it doesn't know about the implementation. And we can have various implementations in different modules. Like a big use case is like stickers, right? Like putting a sticker on your camera. There are many different ways you can get a sticker, whether it's from Drawables or a third party. But not every partner wants to pay for local resources or an API that's really intricate. So, but seeing that factory implementation, I've never seen it done in a academic style like this. So it's cool to see you put that on your deck there. I've always wondered why they use like factory. It's just really just a interface at the end of the day. But I can see why it makes sense in other use cases.
I think like with the example use case, actual factory, I think that's where the premise comes from. Like the last presentation I gave had better design patterns that you would find like built into like OKHP or something like that. So like the interface, the interceptors are the chain pattern. So like, and then I think or like maybe you can do an extension like for example, like you can swap out with OKHP or retrofit the JSON parsing library that you use. So like building out those, they use a lot of design patterns, and it's helpful to be able to speak on those. Essentially, that's why I'm not super familiar with them. So I am using this as an opportunity to learn more about it. So
exactly.
Decorator, I think.
Decorator with
Pattern.
Yeah, I thought the decorator pattern was interesting, and like finding use cases of it, because like we have some very crafty code in this one chunk of our app that I'm trying to think of. Maybe there's some architectural patterns we can use to solve those problems, because the code is very like tangled together and a messy web.
Yeah, so at my work, we actually do use factories for our internal frameworks. It's a nice way to expose like minor public code and have like a default and a mock implementation be exposed privately. So then the factory kind of just exposes, like, instead of square and circle, it'd be like live implementation or, you know, mock implementation. And then they don't know about those actual implementations. They only know about the protocol that binds them. So that's like one example of the factories that we use, which is it's like pretty useful. It's not something I use personally in my work, but it's something nice, I guess, for like consistency throughout like multiple different levels of different types of projects, not just like features, but like just, you know, network services and stuff like that. But the prototype one was pretty interesting, kind of what you had. I feel like the class thing is kind of excessive. I feel like I don't know. I've never seen that before, but I feel myself is like making a protocol in Swift for like structs and
Yeah,
then giving extensions to that and like giving like default implementation. But like, yeah, the copying thing, the NS copying thing is like the worst thing ever. I hate that.
I don't know if I would actually realistically ever implement the protocol pattern because that's not my style, but
Mm-hmm.
I thought it was interesting because like yeah, like in Kotlin, if you use data class, you automatically get the ability to copy. So like, are you gonna rewrite that? Probably not. So I like the Java at Swift. It's funny that there's no built-in copy method. Um, you have to manually implement it.
Mm-hmm.
I
And you
don't.
have to manually implement an NS one, which is like next step. So like super archaic.
Yeah, exactly. I was like, that's weird that structs don't automatically have a copy method like the Kotlin data classes do. But yeah,